Okay, hello everyone. In this project, I mainly talk about Abalone Age Prediction, which is a practical machine learning workflow. So I will gonna walk through the machine learning notebook, which is a focus on the Abalone Age Prediction. So the my purpose of the video is plan to explain the complex machine learning workflow. So there's a game plan for today is an overview. So first we're gonna include problem definition and data preprocessing, module selection, and validation strategies, and also the bias variance tradeoff. So this all concepts align directly with the learning objective of the module one in the practical machine learning. So let's quick go through the next slide. You can see the picture is our main talk about topic. So let's discuss the context of the problem. So why this problem matter? So measuring the age of a balloon directly is a difficult and time consuming. And also often require destructive method. So however, physical machine learning such as size and weight are much easier to obtain. So that will be make the Abalone age a prediction is a meaningful real world problem where machine learning can provide an efficiency and scalable solutions. And for this slide, it's about supervised learning setup. So this tag is mainly framed as a supervised learning problem. So in this learning, the module is training using the label data, where both input feature and the target variable are known. So since the target variable in this case is a bounded age, which is a continuous numerical value, this problem is the best approach as a regression task. So my goal is just for the module to learn the relationship between the physical characters and age. So let's talk about dataset overview. So the dataset is contain several physical features of the balance, including length, diameter, and height, as well as different types of weights, such as whole weight and shell weight. So in addition, so there are categorical feature representing sex of the balance. So to output the variable is a balance age, which module which refer to the predict based on this input feature. So now let's go through data pre-processing. It's very important for this part. So before when I just training any module, like the data processing is required. So one important pre-processing step is mainly involve the handling categorical variables. Since machine learning module typically require the numerical input and the category feature representing the stacks must be the encode into the numerical format. So apart from that, the data set is displayed into the input feature as a target variable so that the module learn only from relevant predictor. So let's go through the next pages. It's talk about validation strategies. So the validation is a critical component of the notebook and of the machine learning in general, totally. So the data sets I was gonna say is split to the training and the testing set. So the training set is used to the feed and the module. So when the test set is reserved for the evaluating module performance on the unseen data. So that will be make approach allow us to assess how well the module generalize beyond the data. So it was training and on the help prevent overfitting. So where a module performed well on the training data, but it will show poorly on the new data. And now let's go through many module choice linear regression. So the baseline module I'm gonna talk about first applying this notebook is multiple linear gen regression. In general, this module serves as baseline due to the symbolical and interpretabilities. So the linear regression assumes the linear relationship between the input feature and the target variable. So when the mix, this mix of module, which is easier to understand and implement, so which will become struggle when the true relationship between the variable is more complexity. So, as a result, the linear regression is often exhibit high bias and low variance, which can lead to the over underfitting for that. And now is like about a tree based on module. So to address the limitation of the linear regression, we totally like we're gonna introduce for the most important module is like tree based module. So obviously like decision tree are capable of the modeling non-linear relationship and interaction between the feature. So, however, like they tend to the overfit the training data, the resulting in the low bias and high variance. So, in order to like mitigate to the issue, so the random forest module will be used so that like I just think like a random forest combine need to combine multiple decision trees and that will be like introduce randomness. So that will be help like reduce variance and improve the generalization performance. So like the picture like that, the advantage, capture, relationship, feature interaction, and non-linear, and so on. And for this part, it's also after like tree-based module is mainly an important thing like that. Like this comparison between the module highlights the bias variance trade-off, so which is core and main concept in machine learning. So linear regression so has a high bias and may failure to the capture complex pattern in the data. So decision tree have the low bias but high variance. So it will be often fitting noise in the training set. So and the random forest is just focused strike a balance between these two extremes by reducing variance while maintaining sufficient module flexibility. So this module like trade-off, it just play the main role in selecting a appropriate module for the given dataset. So there are the three bullet point like the linear regression. So it will be show high bias. The data decision tree will be show like high variance, and the random forest is just all totally like balanced. And next is talk about like our result module compression. So when evaluating the result, it just become the like clear that the linear regression module interface the data and it does not like achieve strong predictive performance. So I choose like a tree-based module perform better by capturing more complex relationship. So among them, the random forest module demonstrate improved generalization on the test set. So that will be like indicating that ensemble method can be effectively balance bias and variance to achieve more reliable prediction. And for this part, like, is about real world implication. So as far as I know right now, from the real world perspective, these findings are highly relevant into our daily life. Like machine learning module like this can significantly reduce the need for manual age estimation of the abundance. So, however, the choice of the module has a direct impact on reliability and the deployment success. So without the proper validation, even high-performing modules may fail when they just apply to the new data. So that mainly like reinforce the importance of the validation in practical machine learning applications. So it's very important. So the total like in conclusion is like about the final takeaway is the last part from our today game plan. So the notebooks is mainly talk about like demonstrate a complex end-to-end machine learning workflow for regression problem. So it just mainly emphasizes on the importance of the data, pre-processing, validation strategies, module compression, and understanding the bias variance trade-off. So these three like concepts are very, very essential for the building robust, interpretable, and trust machine learning module. So they just form like foundation of the real world application. So thank you guys.